Hi, and so this is Mr. Benson, and I'm going to um, emphasize something because two people have taken this quiz and they both made the same error. And that means that the lesson wasn't good enough to make sure that you understood. And so I'm going to see if I can clarify things. So the first thing is that, if I have a right, or not a right triangle, a triangle like this, and let's say that this was 92 degrees here, and then this was 35 degrees here. And so that would mean that the total degrees that I have so far would be, let's see, that'd be 127, right? If I added that right, let's check. 35 plus 92, 7, that's 127 degrees. So because in a triangle there's 180 degrees, that I want to find this other angle here. So this angle right here would be 180 minus 127. So then this would be 3, and I borrowed from the 8, so that's 7, and that's 5. So this would have been 53 degrees. Okay, so if I want to use trigonometry, the goal here would be to find this other angle here. So let's say that this was, maybe this side length of this triangle was 20. I don't know, 20 centimeters. And I want to find, and I know this side of this triangle, maybe this is 15 centimeters. But I want to find this other side, this side X, opposite the 92-degree angle. Well, that's a problem because I can't use trigonometry because I don't have a right triangle. Notice that the angles of this triangle are 35, 92, and 53. So if I'm going to use sine, and some people are pronouncing it sin. Remember, it's even if it's written S-I-N, it's sine. We say sine, not sin. I understand what you mean, but people are going to look at you funny if you say that. So sine and cosine. So that only works for right triangles, and we can see clearly this is not a right triangle. You all can tell that. So what you have to do is you have to split this triangle. Many people that I was looking at, or the two people, they were splitting it like this angle, sort of like sideways. Well, that does not make a right angle. To make a right angle, this has to be perpendicular. So what I need you to do is when you make that line going down, it has to be a perpendicular line to make a 90-degree angle. Once you make a 90-degree angle, then you have two right triangles, and now we can use sine and cosine. So we have two parts at this point. So we have this length from here to here, and this length from here to here. So I already used the variable x. So let's call this side A and this side B. And clearly everybody sees that x equals A plus B. So that means that if I can find A and B, then I just add them together to find that side x, which is what I want. So let's look at the smaller triangle here that is got the 53-degree angle and the 15 centimeter side. So what I need to do is I need to find this length B. So this 53-degree angle, acute angle, is in a right triangle. And so adjacent to that is side B, and the hypotenuse is 15. So I'm going to do this in blue, and I'm going to say that cosine of 53 degrees equals B over 15. So B equals 15 times the cosine of 53 degrees. That will give me length B. Then for the other length, I'll do that one in green. So we'll call that, we said we're going to call that A. So here's A. And A is in this right triangle that has a 35-degree angle. I don't know what this angle up at the top is because remember it was 92, but then I split it into pieces. But I do know that this is a right angle down here because I drew that line to be perpendicular. And so now when I draw this, I'm going to say, okay, the adjacent side to 35-degree angle is going to be A. And so I can say the cosine of 35 degrees equals a over 20. And so now I have a equals 20 times the cosine of 35 degrees. And now I just have to do this on my calculator, the 20 times the cosine of 35 degrees and 15 times the cosine of 53, and then I'm going to add those together. And I just noticed that one was 35, the other is 53. Well, that's just coincidence. That's not there's no meaning behind that. 20 times the cosine of 35 to 1 decimal place is going to be 16.4. It was 16.38 something. And then 15 cosine of 53 is 9.0 to 1 decimal place, 9.027, etc. And so when we add this together, we're going to have the answer, that length, is going to be 25.4, and I think the units we were using were centimeters. And that's our answer. Value of 20. And so this new length right here is 5.4 centimeters. So our original triangle has sides of 20, 15, and 25.4. And of course, the original triangle was not a right triangle. Hope that helps. When you do problem 2, this should be the way you do it.